This video is brought to you by PCBWay. More about them later. With this video, I am embarking on a journey into the world of neuromorphic and wetware computing. Neuromorphic computing is an approach to computing that mimics the way the human brain works by electronic circuits, while wetware computing uses organic material such as living neurons. So let's waste not any more time and get started building. Fortunately, PCBWay has agreed to sponsor my project. PCBWay is my favorite all-in-one fab. In addition to all kinds of PCB services, they offer CNC machining, 3D printing, sheet metal fabrication and injection molding. The quality is outstanding, their prices are reasonable, and you usually receive your parts within 1 week. All of this is backed by a very friendly customer service team that you can contact at any time. The metal plating you see here on the PCB is called electroless nickel immersion gold. It remains to be seen whether living organisms can be grown on it. Otherwise, glass could be used as a substrate with traces of pure gold. I populated some of the PCBs off camera, but I will show you later how to populate a PCB using a stencil. The chip on the PCB is a 74HC4051, a single 8-channel analog multiplexer. I am utilizing small centrifuge tubes as containers, which I cut apart using a very simple jig. To bond the tubes to the PCB, I use 2-component epoxy resin. I use a toothpick to apply as little adhesive as possible. Under no circumstances should the epoxy resin seep inside, as it could cover the electrodes. It's almost impossible to apply a clean bead of epoxy resin to the outside of the tube without a special tool. That's why I built this device. It consists of a gear motor and a shaft coupling into which I glued a tube cap. Here's what else I ordered from PCBWay for this project. Ordering parts is very easy. Just go to their website, sign up and upload the design files. Most of the time you will get an instant quote, so occasionally the file needs to be reviewed by an engineer first. If there are any questions, you will receive an email. After payment, you can track the production status of each part in real time. To measure the voltage potentials generated by the neurons, I use the ADS1115, a 16-bit I2C compatible ADC with programmable gain amplifier. Since I'm sick and tired of flimsy jumper wires, I've been making my own for a while now, using this kit and silicon-coated wires. And that's like the finished experimental platform for Wetware computing looks like. I plan to use red neurons, but I still need to do more research and build a few things, like an incubator. The ultimate goal is for both the Wetware and the Neuromorphic computer to learn how to play Pong and play it autonomously. During my initial research into neuromorphic computing, I was surprised to learn that it is very difficult to get hold of neuromorphic chips. My top choice would have been the CM1K chip with 1024 hardware neurons, but it has completely disappeared from the market. Finally, I found the Intel Curie Neuron module from DF Robot. It contains the Intel Curie chip with 128 neurons, which uses the same technology as the CM1K chip. The module can be programmed via the Arduino IDE. Just select the Arduino 101 as the board. Since the module itself is useless, I designed a PCB for it. I also ordered a stencil from PCBWay to apply the solder paste. And boy, did they do a great job. The silk print is crystal clear. My German PCB manufacturer can't even come close. To minimize the thermal stress on components, I use low melting point solder paste. When applying solder paste, it is important not to use too much. The cutouts in the stencil should be filled completely, but not more than that. Otherwise, the access will cause many solder bridges, especially with components that have a small pin pitch. I use my rework station for reflow, but you can also use a hot plate or an oven. Whenever possible, I try to heat the components themselves as little as possible and direct the hot air stream at the pins. It's best to use a small nozzle. I use isopropanol and a toothbrush to remove flux residues from the PCB. These residues are highly corrosive and should not be left on the PCB for long. To get familiar with a new microcontroller, I usually start with a blink sketch, which I did. The third PCB I ordered from PCBWay was populated in the same way. The programmable waveform generator is needed for the Memristors. I bought them here. There are many reasons why memristors are useful for a neuromorphic computer. One example is the perceptron. You may notice that a perceptron behaves like a summing amplifier. The adjustable weights are represented by potentiometers. The problem is that these potentiometers can only be adjusted manually. However, they should adjust automatically after each previous error calculation. Frank Rosenblatt, the inventor of the perceptron, used potentiometers with servo motors in his Mark I perceptron computer. Today we could use digital potentiometers, for example, but a very elegant solution would be the use of memristors instead of potentiometers. Last but not least, I'd like to show you a chemical neuron I've been working on for some time. That's it for now. There will be a second part once significant progress has been made. Thanks for watching. Stay true, stay you.